Hello everyone, my name is Ryan and I'm going to be giving a short and sweet tutorial on how to use KiCAD. KiCAD is printed circuit board PCB design software split into two main sections, schematic design and PCB layout. The schematic contains all of the theoretical electrical connections that need to exist in the circuit, and it does not exist in reality. It is exactly as if you were drawing a circuit on a piece of paper. So let's go ahead and create a new KiCAD project by doing this. We'll go over to my home directory and create a new one called tutorial. Now we'll launch the schematic editor by pressing this button. So, in our circuit, you have wires and components such as resistors, capacitors, and microchips. Wires just show how the different components are connected to each other. To place components, use the right-hand menu over here or press the A hotkey. This brings up a list of different libraries that all contain components. So let's click to place one. These are all the different libraries. So you can search their components by name or look through them all manually. Let's add a resistor by searching for R and then pressing enter. Zoom in a little bit and place our resistor. Select the component and click to place it on the schematic. It's pretty easy. Now let's add an LED. So A, LED, enter. And then we can rotate this by pressing R. Let's rotate it a few more times. Now we'll place it there and we're good. So now we need to connect the resistor to the LED. We do this by using wires. Either use the right hand menu over here or pressing W, and then select the ending location for the wire. If you're curious about what hotkeys to use, just press the question mark. It'll show you everything you need to do. So, now that the LED and the resistor are connected, we need to provide power. Add power sources by pressing P or using this button on the right. P. Now, let's go and look through power. We see there's tons of different voltages. We just want 5 volts, so let's put it into the filter. 5 volts. Enter. We provide this 5 volts over here and connect it up. Now we'll need ground. Power, ground. Press enter and place it. So, we need to provide a means of actually providing power to our board. Just placing these theoretical power supplies on the schematic doesn't mean our circuit magically has a battery. We're going to have to put this in somehow. So, let's add a connector that we can connect our battery to once the circuit board is complete. We'll just need a connector for 5 volts and a connector for ground, so we'll use a 1x2 connector. We'll place it right here and connect pin 1 to power, 5 volts, and then pin 2 to ground. Now we'll need to add the wires here, and we're good to go. I'm going to quickly make this circuit a bit more complex for showing how PCB routing is done later. I'm going to add a microcontroller and some port circuits to this board. So, now we're at a point where labels are going to be useful. Instead of connecting a wire across from these different pins to all of these different pins, we're going to create labels, so we can just have a wire coming off here to a label, and then a wire going over here to another label, and then that'll act as an actual connection. So we can use a label by doing this. We know this one needs to be called MOSI, master out slave in, and we'll put it here. We'll connect this to pin 1 with a wire, and we know this needs to be connected to this pin right here because it says MOSI, so we'll add another label by pressing L. Type in MOSI. It has to have the same name and it's case sensitive. Connect a wire between there and we're good. Now these two things are physically connected. This is really nice for organizing your PCB. If you're trying to make this go to multiple different pins, it's super nice because you don't have to route it all the way down here. So labels are really useful. Make a lot of use of them. I'm going to finish up the rest of this board, so I'll see you in a second. So, now that our schematic is complete, we need to bridge the gap to the real world. We need to do this by assigning a footprint to each of the different components shown here. A footprint is a copper design that a physical chip can sit on so that we can solder it onto our board. Footprints come in all different shapes and sizes. Footprints have two types, through-hole and SMD, which stands for Surface Mount Device. SMD only takes up one side of the circuit board and is usually more compact, while through-hole is easier to solder but takes a lot more space. Common SMD resistors, capacitors, and LED footprints are 0805, 0603, 0402, and 0201. 0402 is getting pretty small, and 0201 is basically a grain of sand. I tend to use sizes 0805 and 0603 so that I can put the chips on the board. To figure out what footprint you need, you'll need to find the part that you want on DigiKey or Mouser. This is going to be a real thing that you want to buy. It will define all of the sizing and footprints that you need for the PCB. Typically, look online for these parts. So to assign a footprint to each one of these components, we need to go up here to CV PCB and click on this. Select yes to annotate. This is just going to change all of these question marks to numbers so that everything has a unique name. We're good. So these are all of the different components that we have on our board. So we know for the capacitor we're going to want to use this 0603 because I've selected parts beforehand. So we're going to go down to here, go to capacitor, SMD, select 0603. Diode, we're going to use an 0603 LED. Done. And we're going to continue doing this for all of the different parts. So I'll see you guys back in a second when I've finished all of this. Okay, now all of our footprints are assigned, so we're going to exit out of this. Now we need to go and generate a netlist. Generate a netlist by clicking on this button. Click generate, save it as whatever you would like, and then we're done. Now launch PCB new to start laying out our circuit board. This is where reality comes into play. The very first thing that you should do when designing a circuit board is to define the dimensions that you want it to be, and then draw the edges. Draw them using the line tool right here, and select the edge cuts layer. There are all kinds of layers that you can use. The most important are FCU, which is front copper, and BCU, which is back copper. Silk screen is where all your different logos are put, and there are tons of different layers you can use. Most of these are ignored. You can select render to make sure it doesn't show some of them if you don't want to see them because they're getting in your way. So let's quickly draw some dimensions for this circuit board. Okay, so we've now defined how big our circuit board wants to be. The next really important thing to do is to define the design rules, such as tolerances of how close connections can be and how large a vias should be. This information is provided by our PCB manufacturer. I typically use OSH Park, and the design rules are listed on their website. So, to modify the design rules, go up to Design Rules and select this. We can modify all of these defaults. OSH Park asks for 6mm trace width, 6mm clearance, 15mm clearance on board edges, 13mm drills, and 7mm annular rings. So I'm just going to set the clearances slightly higher because I happen to know what they need to be. And we'll call that good enough for now. Now, we've got the start of our circuit board. Vias are holes in the PCB filled with copper that connect the front and the back layer. Traces are electrical connections on the PCB and are essentially embedded pieces of wire. They're just small strands of copper. To make your life easier, you can add completely filled copper regions. Typically, this is called a plane and is done with a ground to make connections easily have a ground connection. So, once all our edges are outlined like this, we need to place all of our components. So we need to load the netlist. Press this, read current netlist, yes. Now, all of our PCB components have been placed over here. We can move them by right-clicking and selecting Move, or we can just press M over them. So let's just move a few of them around so that we can have a good idea of what we're working with. So what you can see here is called the rat's nest. We need to essentially lay out all of these components to minimize all of these overlaps because every one of these needs to be a physical wire connection. The rat's nest shows us what our schematic has defined as our circuit. So the first thing that we should do is physically place all of our parts on the PCB, and then we want to route them. So I'm going to lay out some of the board now, and I'll kind of speed it up because it's kind of an art form to get these all working together and minimize things. So it's important to know that you can use 2 layers. So if I wanted to move this to the back layer, red is the front and green is the back, I can do move, and then I can press F to flip it. And now we can see that I can actually place these just on top of each other, but this one's actually behind it on the back of the circuit board. Using both layers really helps on making things a lot more compact. Let me finish up designing this circuit board for you. Now we've got everything laid out properly, and we're going to want to do all the connections next. So let's add a ground filled layer on the bottom. To do that, I'm going to select Add Filled Zones, Back Copper, Net Ground. We can set other parameters here. Then we're going to define a polygon. One side is here, another side is here, another one over here, and then we'll finish it up right at the start there. And now, as you can see, that filled up a huge different part of the circuit board with ground layer. So that finished up some of our connections for us. Now we can show which side is, now we're looking at the back in front of us. Use page up and page down to switch that. So now we're looking at the front. So let's finish up some of these electrical connections by routing it. We'll add tracks and vias here. So we can see it's nice and interactive. We can click and change how it works with things. This actually needs to be on the other layer, so I can press V to place a via to go to this layer, and now we're connected. Let's finish up some of these connections. Page up to switch to the front side, and go over here. This needs to be connected to underneath, add a via, connection. So, it looks like I finished this fairly ugly routing job, but it doesn't. So, let's perform a DRC to make sure that everything's connected properly. Start DRC. It'll show me any errors near here. So these are pad near pad. That's kind of a non-issue because it's saying that these pads are too close to each other. There's nothing we can really do about that, so we're just going to have to ignore that one for now. This one is a more serious error, unconnected pads. So it looks like one of these pads is disconnected. Looking here, it looks like this ground is not connected to anything else. So let's add a connection there. It should fix our problem. Now let's save that. It looks like now we have some more connections. Let's correct this. Now, let's see if our DRC passes this time. Pad near pad, unconnected pads. There's still one pad unconnected, so let's take a look really quick. If we read the DRC more closely, pad 1 on BCU of R2. So this needs to be connected to ground. Ah, that's quite sneaky. So, via here. There. Now let's finish the DRC. Pad near pad, no unconnected errors. Perfect. Okay, so our circuit board is complete. Let's take a quick look in the 3D modeler to see how it looks. Now as you can see, this is what it'll look like when it's fully assembled. Pretty ugly, pretty simple board, but that's the basics of how you design a circuit board.